We will measure the magnetic field here for calibration and error analysis purposes. This is the magnetic field sensor we are using. The sensor is at the tip, and this is the face that's perpendicular to the z-axis, y-axis, it's upside down, and the tip is perpendicular to the x-axis. So in this orientation, most of the magnetic field due to the coil should be along the x-axis. We will first measure the background magnetic field. This should be measuring the geomagnetic field. The graph plots 4 plots. 3 of them are x, y, z components of the magnetic field, and one of them labeled B field is the magnitude of the magnetic field vector. So this is the Earth magnetic field, about 0.3 Gauss or 0.03 millitesla. Okay, so we will turn on the apparatus and apply about 1 ampere of current clockwise. And measure the magnetic field. Because the Lorentz tube blocks the way, we can only measure the magnetic field around the Lorentz tube. So this will be more useful for double checking, sanity checking our data. Later on, we are going to remove the Lorentz tube and measure the magnetic field at the center of the Helmholtz arrangement. This is for 1 ampere. And we will apply 2 ampere of current and do the same measurement. The variation of magnetic field here shows the worst case scenario because we are measuring it outside of the experimental region. The data that's being plotted here will be available as a comma-separated value file. Make a note of the dataset title. Right now we are collecting dataset 3, and you will see the data referred to by the set title you see in this video. So this is for 2 ampere. Now we are going to reverse the direction of the current, hence the magnetic field. We'll apply the current in counterclockwise direction and measure the magnetic field again. So far you have seen that the x component of magnetic field is about the magnitude of the magnetic field. And with the magnetic field direction reversed, you see that the x component is now negative. The significant z component of magnetic field worries me a little bit, but it's probably not the biggest contribution to the error. But you should double check that. Okay, we will apply 2 ampere of current, and this is the last measurement we will do with the Lorentz tube in place. Again, the variation of magnetic field here represents the worst case scenario. Okay, now we are going to remove the Lorentz tube so that we can access the actual experimental region and measure the magnetic field there. I turned the power supply off so that nothing breaks as I remove the tube, and we will see how uniform the magnetic field is in the center of the Helmholtz coils. Let me put this away where I won't accidentally break it. That's the background field. I should probably actually measure it to show that the background field hasn't changed. And I'll zoom in after it finishes collecting data. Again, the comma separated value file will be available. So still about 0.03 millitesla of the geomagnetic field. Now we will apply 1 ampere of current, and I'm going to try to start the sensor from about the same location as before and then move it into the center region. So this is the magnetic field in the center region. You can see how little it changes. And I'll move the sensor along the axis to see the variation. And this is the portion you can probably use to compare to the previous data with the Lorentz tube in place to make sure that nothing substantial changed in the removal of the Lorentz tube. Now this is with 2 ampere of current. And again, the center region magnetic field and the variation of magnetic field along the axis. You can see that in the center it's fairly uniformly about 2 millitesla or 20 Gauss. Okay, so that was the clockwise current with the magnetic field pointing away from the sensor. Now it's with the counterclockwise current, the magnetic field points into the sensor, about 1 ampere of current. And this is the magnetic field in the center region. And how the magnetic field varies along the axis. Next measurement is the last measurement, 2 ampere of current going counterclockwise. This is the magnetic field in the center region, fairly uniform, close to 2 millitesla field. And this is the variation of magnetic field along the axis, from one loop to the other loop. So that's the measurement of the magnetic field. This should be used to calibrate the calculation of the magnetic field based on the current values. For the experiment itself, only the current measurement will be available. And this is the apparatus 1. I will make another video for apparatus 2.